Very official.
I wasn't sure if it was going to show up. Welcome to the February meeting of the BBAA.
Can I make a motion to dispense the reading of the minutes of the last meeting already?
Yes.
We hadn't got there yet.
I'm getting there. I'm getting there.
Jeez.
We can
I want to hear any
always,
minutes.
suspend the reading and tell everybody to go look it online. That's where we got them.
I second that.
All in favor? Aye.
Aye.
This is a preemptive strike on Jeff.
I want to hear me talk. Okay. I'm fine with that.
Okay, let's go roll into the Vice President's report with George.
Okay, let me share the screen here. Okay, here is this month's calendar. Here we are tonight at the meeting. Corn Watch tomorrow night. Sky Watch on Saturday. All right. Next Friday is our second Corn Watch at Cornland Park in Chesapeake, and Night Watch at Chip Oaks Plantation State Park on the 13th, Saturday the 13th. I posted this on the Facebook page. On the 18th, the Mars rover is supposed to land on the moon. I mean, on the moon, on Mars. And if you go to this link, I have 12 p.m. because I don't know the exact time, but you go to this link and pull up this, there is a link to go to nasa.gov, and NASA is going to cover the entry, descent, and landing of Mars 2020 Perseverance rover. So you can go to this link, and I will post this link on Facebook and in the groups IO as well. Going the wrong way. Okay, back to the calendar. Okay, that's the 18th. That's 2 weeks from today. Mars rover lands on Mars. Then on Saturday the 27th is our scheduled Saturday Sunday at Elizabeth River Park. And that's it for the month of February. Okay, if we go to the next month, March. I'm not sure what this is. River's Edge Liberty Star. I'll have to, let me see here. River's Edge Liberty. Oh, yes. This is a request from Jasmine Stover at Portsmouth Naval. Single Sailor Program at Naval Support Activity, Hampton Roads. This is tentative. It's probably not going to occur on the 1st of March, but she threw that date out as just a possible placeholder. So there'll be more information on that later. We're still trying to come up with a dark, semi-dark sky somewhere near Portsmouth. Good luck. Okay, back to March. Okay, a month from today, on the 4th of March, is our club meeting. Again, Corn Watch on Friday the 5th, Sky Watch on Saturday the 6th. The following Friday is Corn Watch again at Cornland on the 12th. Saturday the 13th, Night Watch at Spokes Plantation State Park. And I think this was scheduled last year, Nansemond Suffolk Academy. I'll have to check back with them and see if they're still planning on doing that. That was scheduled a year ago. There might be a change, not due to COVID, so I'll check on that one. And then on Saturday, the 27th is our Saturday, Sunday, March 27th. And that's pretty much it for the month of March. I don't have any garden stars scheduled, but when they ask me to schedule one, I will put it on the calendar. Any questions?
As of last night, the Staunton River Star Party, it was still scheduled as a go. It has not been canceled yet. And that's between the 8th and the 13th of March.
Okay, the 8th through the 13th of March is a Stanton River Star Party, which I would love to go to that. We'll see what happens. I hope it goes off. Any other questions or comments?
It hasn't been canceled, but they're not taking reservations yet either.
Okay. Okay, I'll try to put something up on the website or the Facebook page to go to their site to check periodically to see when if they're going to do it. Okay, any other things? All right, I guess that's it.
Thank you, George. Let's see, next we will go straight to the Treasury Report since we skipped Jeff.
All right, this is going to be a great Treasury Report. I got nothing. Now, I was hoping Chuck would be on because Chuck finished the books for January. I haven't opened the stuff, and I'm taking it from here, but I just have not had time to even look at anything he sent me or follow on. So that's going to be my weekend.
Saying Chuck left and so did the money.
That's what I thought he was going to say.
Chuck's on his way to Colorado with all our money.
Yeah, I haven't logged into the checking account in a few weeks since he drove by and dropped off all that stuff. So that is a possibility. We'll find out next meeting. I'm like, we're cleaned out. I have no Treasury Report.
That's
sorry.
fine. That's fine. When you get the information, just go ahead and send it to Jeff so he can add it to the minutes.
Yeah. He did the books for January. I was going to go do them independently to make sure that everything I did matched with everything that he did because he has some kind of quirky ways. We've kind of gone through it. Understand what he's doing. I just want to make sure that I can replicate. And then I'm going to improve upon some of his systems.
Sounds good. All right, I don't see Ben on, so no scholarship report. Let's go to the Alcor. Bruce?
On that note, before we get to Bruce, I will say that, we took money hits because we didn't have events like Boardwalk Astronomy that brings in money. But a lot of club members have been generous and I've been seeing coming through the PayPal where people are just donating their own money to fill that gap in the scholarship. So next month, when there's an actual Treasury Report, I'll report on how we're actually looking scholarship wise. But people are donating.
Sounds good. Thank you, Rich.
Hey, Sean, I do have a bit of a report for the secretary.
Okay, go ahead, Jeff.
I spoke to a gentleman out of Chip Oaks about the permit. Has anybody been to the post office box lately to see if a permit has shown up?
Chuck went by like a week or two ago.
Was there a Chip Oaks sign permit in there?
Email. Let me see if he mentioned that. I know he found a bunch of money in there.
Well, I spoke to him, and it seems like the holdup was about the December date. December 5th, they're having a deer hunt down there, and it's closed to to everybody. They don't want people out and about with other guys running around with guns, which I understand. So apparently that was the holdup. And the guy I spoke to said any of the other dates were just fine.
Yeah,
see
we're gonna change our Skywatch date to the date that we were originally going to go to Chapokes. So that's gonna be what we're gonna do in December. Instead of going to Chapokes on that Saturday, we'll do it at Skywatch. We'll go to Skywatch at Northwest River Park in Chesapeake.
Okay, to switch it up. Okay, that's what I was suggesting. Okay, good. And Sean, you got the Osprey Shelter at Elizabeth River Park for July 17th. And George has got reservation for Stripers for our luncheon on December 11th. Okay, that's all I got.
All righty. You ready, Bruce?
Yes. Hold on. I thought I was ready. Okay. All right. So, good evening, everyone. I'm the coordinator of the Alcor. So, first of all, I want to congratulate Mr. George Reynolds for successfully submitting and completing the Astronomical Conjunction A Award. Good for George. The thing I held up earlier is the cheap man's version. You know, I didn't actually go to Portland and get massive amounts of media coverage for the rest of the time. So that's just a downloadable certificate, but George did receive that award, and we corresponded January 19th. The deadline for submitting for this award is the 21st of February, this month.
Yes. Yep.
And we'll put the link to submit and all the stuff that you need to do for that in the chat when I finally shut up. But George mentioned that Mel, Chuck, Jeff Goldstein, and Eddie Paris were also involved. So if you would like to submit for that, I welcome your input that astronomical website. During COVID, I'm really not hung up on bureaucracy. Everybody here is professional, knows what they're doing. So you could submit directly to the coordinator, and that's listed on that website. His name is Alan Clemenson. George, do you have any issues submitting directly to Mr. Clemenson?
I mailed mine to Aaron Clevenson, and Eddie, I believe, emailed his. Didn't you, Eddie? You're muted, Eddie.
Okay, yeah, yeah, I did get mine, and yeah, and I did email it.
And you got your certificate, your downloadable
Yes, I did.
certificate.
Yep.
Good.
Okay, so the link to submit for that award by February 21st is now in the chat. So George and I are on a campaign to get more BBAA members into the back of the magazine again, to start getting, pins. I'm gonna have two little pins right here. Anyway, these are outreach awards, but you get a nice pin, and yeah, it's kind of like jobs for adults, but everybody needs a pandemic project. You can make this any of the other observing programs one of your pandemic projects. In the back of the reflector, you can order different program in books that summarize different programs. I've circled the globular clusters program here that I need to finally order. So anyhow, these manuals walk you through full programs. You don't have to invent all this from scratch. You accomplish everything you mentioned, find all the objects that you talk about, and submit it. And yep. So other than that, I looked at the Mideast Astronomical region of the AL website and the Astronomical League website, and there's nothing new there other than that the award by the end of February. Thank you.
Thank you, Bruce. Does anyone have a report on triple RT? I'm looking right now to see if it's actually up. I think I got a link saved here on my computer for it. Actually, wasn't it under the home page or on the website itself?
On there somewhere. It's hard to find.
I think I put it under About Your Club. Yep, there it is. Let's see if it's even up. Well, since we have some people here that may not be familiar with this, let me just share this real quick. This is a status report for the triple RT, and it says nothing's available. But on this Skynet robotic telescope network, we have access to the triple RT, which is a robotic telescope on Fan Mountain that the club members can use. And last meeting, it was available too. So I don't know what's going on tonight, but you look at the different, these are all the telescopes that are on this network. And this gives you a status on them. Not sure what's going on with the triple RT, but it'll probably be up in the future. So if you're a club member and you need access to this, let us know. And a guy named Bird, he works over at NASA. He's our contact point. He would set up an account for you. He's not on here tonight, but we can get a hold of him if you want access.
Yeah.
So I guess we'll roll into old business. And as Jeff mentioned, I have paid for the Osprey shelter at the Elizabeth River Park. And we have until, technically they said 15 days before July 17th is the date, if I remember right, that we can cancel. And we have to like pay a $15 cancellation fee. But I figured we'll know in June what the status is with COVID, if we're going to have it or not. And let's see, the only other old business that I have is Rich brought up, I believe at the last meeting, about needing input for the newsletter. I know I saw some comments about it on the Google I/O site too. If you guys have any, even if you're new, if you have any stories about astronomy, write up a little paragraph and forward it on over to Rich, and he can add it into the newsletter, and you can be famous.
And so far, nobody has sent me anything.
I'll get you something. Have you reached out to Kent Blackwell?
No, I just sent it out to the distribution network on Groups IO. So that's 200 something people.
Okay.
If I don't get response, I'm going to start like trying to ping certain people and coax things out of them.
I'm just going to send
I'm
you
hoping I
something.
have more bandwidth to work on other projects here later in the month. But
Yeah, don't be shy sending.
I've had not much free time or sleep in the last 2.5 months. So, but,
Hey, Rich, I don't monitor the groups.io site, but I do monitor the Facebook site. So I've submitted articles in the past.
yep.
Try to send you something. I would repeat your plea on Facebook.
Yep, will do.
I've been a newsletter editor. I know what it's like.
And that's the only old business I have. Does anybody else have any other old business?
I do. Chuck passed off to me a box of T-shirts that are still unclaimed. It's still in my car. I should have brought it out to look at it and see who we owe a T-shirt to. But they're already paid for. We've got T-shirts that are paid for, and also we've got some T-shirts that are extra. We got spares for sale, and I think they're large and extra large. I don't know if we have any mediums, but I'll check and I'll put that. In fact, I could put that in the newsletter. How's that?
Yeah.
Yeah. You can put it on Facebook too.
Okay.
So if anyone's interested, I mean, I would show you, but my head's floating. I'm wearing one. It just happens that my shirt is blue and so is my background apparently. And so I've just disappeared into it. But they are pretty nice shirts. I like this last one we did. It seems like the embossing part is going to stay on a long time. Let's see. Anybody else have old business? All right. How about new business?
I've got a new business, kind of an announcement. I and 68 other professors at TCC met with the academic president of the academic affairs, Dr. Woodhouse, and she said she's really shooting for September full classes. However, they're going to be wearing masks, so I'm just thinking ahead. Maybe we can meet in September in person. I'm just saying maybe. I don't know. We can do this ad infinitum on Zoom. I don't mind, but I'd rather meet in person.
I agree. I would rather meet in person too. I mean, I think most of us would when we all know it's safe. Just keep us abreast of what's going on, Jeff, because I think that in the future, what we're going to end up doing, like you set up before on Facebook Live, and I'm pretty sure that this Zoom thing is going to just be a standard from now on. We're just going to have someone do it from the classroom where we're all meeting, so the people that's not there can still see it. I mean, I finally signed up on here, and 100, you could have 100 people. If that's the case, we're never going to have a problem. We never have 100 people viewing and at the meeting. So we'll probably be good.
I think the limit for me is 200 or 300. So I think we're good.
My question is, it's available to everybody. I don't think we've ever had more than 17 people online at all at any one time.
Yeah, we get more people in person.
I know.
You're
That's
saving
because I
the-
think most people prefer to meet in person. And I mean, as soon as we're able to, I say we go back to it.
I mean, I'd rather go in person. I live over an hour away from TCC, so it's a long haul for me, but I would still come.
I enjoy it. I think we all do. Alrighty. Anyone else have new business?
Oh, Chuck just signed on.
I missed the parking tickets from TCC. So sorry, Jeff.
You got a parking ticket? Where were you parking?
That's classified.
Oh, back. I
My wife
wanted
misses me having to buy her a Frosty on the way home for her to eat on the long drive.
I don't want to pressure anyone that is here for the first time, but if you have any questions, this is the time that you can go ahead and ask them. Or if you're new to the club, you can introduce yourself, which is what we normally do in person too. But like I said, it's only if you want. Is there any other new business though from anybody?
Just new puppy.
I saw that.
Feeling your thunder back there.
Uh-huh.
I'm new to popping in right now. I haven't joined. It's something that I'm, pursuing, and just as I don't know if you were here earlier, I said that I got a new scope for my birthday in January, and so I'm looking to learn more. If there's any kind of literature that you all would suggest, I'd appreciate that. If you want to drop it in the chat, I can look it up. And then I'm looking forward to maybe stopping by on Saturday and seeing what I can learn there.
Sounds good. And
This is the
George,
best way.
if you could add in chat all those books that you recommend, like turn right at Orion and everything? I know you're I can see you typing already.
I figured I
Right now.
know exactly what George is putting in chat right now.
As soon as you said it, George is one of the most knowledgeable members we got, and he's definitely helpful if you have questions. He's the one up, VP George Reynolds.
Yes, I see him.
Yeah, and welcome to the hobby. Hopefully it develops more into that. If you have questions about operating the telescope, let us know.
How
Yeah.
does that work? You all meet up at what time is it? At 5 and set things up, and then you allow like somebody like me to come and look through your.
Yes. Yeah, we meet up. We'll be there typically an hour before sunset, and as it gets later into the summer, you know, that time will change.
Right.
And we help people that are having trouble with their telescope figure it out for when it's daylight still. And then
Yeah.
the event starts at sunset and lasts for 4 hours. And any telescopes that are there, you can look through. That's why we have them set up.
Mhm.
I mean, obviously with the pandemic, just make sure you're wearing a mask, social distance
Okay,
stuff.
that was my next question. You know, do you have any rules for that? But I assume the masks.
Unfortunately, you don't just try not to touch the telescope, because you can't really clean the telescopes with these hand sanitizers because they're sensitive equipment, and you don't want to be putting on hand sanitizer on like the lenses and everything. So the best idea is just don't touch the telescope and you'll be okay. And wear a mask.
So on the subject of Skywatch, one of my favorite apps is Astrospheric. And 5 o'clock on Saturday, 6, looking pretty decent. 4% cover. 32, 2.21 Fahrenheit. Don't wear shorts. I've seen it. They don't last long.
Don't wear what? I didn't hear.
Shorts.
Wear warm clothes. There was a lady there showed up last month. It was 37 degrees or almost 38 degrees, and she had open-toed shoes. No socks.
Chuck has seen the fashion parade, as have I. So.
Yeah, basically in the winter, there's a restroom which I think is locked right now, but they have a porta potty, but it's rural area. It gets cold there at night, but this is the best time to go too, because you can, if the sky's clear, you'll have your best viewing in the winter. And if you show up there in the summer, bring the bug spray.
No shorts. I got it.
If you're brave, you can.
General rule of thumb, dress for about 20 degrees colder than it is.
Yes.
Because standing around, you get cold.
Feet get cold.
Which one of you has
head
those
gets
hand
cold
warmers?
quick.
Yeah, my granddaughter uses hand warmers and puts them in her shoes. Okay, I posted 2 books, Turn Left at Orion by Guy Consolmagno, Night Watch by Terrence Dickinson, and a couple star atlases, Pocket Sky Atlas, it's put out by Sky and Telescope magazine, and Objects in the Heavens by Peter Buren. And let me give you my email address so you can, if anybody has any questions, you can just email me and I'll give you more information. For instance, that Objects in the Heavens is a little small pocket-sized book, nice to have at the telescope. But you can't get it on Amazon. You have to go directly to burendesign.com, and I can give you that link if you ask me.
Chuck, did we sell all those moon planners things that were like the pocket guide, or do we have any?
I've got those too. Chuck gave those to me.
Okay, yeah, those are good too.
Yeah,
That's
you
right.
didn't even let me say I stole the money from it.
You said that earlier when you were here.
Yeah, when
Oh,
you didn't
good.
show up, we figured you're on your way to Colorado with a bunch of money.
Yeah,
Telescope.
that's it.
Chuck, are you?
I've turned into chief cleaner and house painter.
Chuck, are you in Colorado now?
No, we're still here. We'll probably be here. It looks like now that probably the earliest we're going to move is sometime in April.
It always takes longer to do a house than you plan.
Oh yeah, we're yanking out all the popcorn ceiling, and that's a new experience too, right? And so then we got to paint the ceiling and then paint the walls and stuff. And right now we only have one room completely done, but we have the next biggest set of rooms all stripped and ready to go. And we found out that we have to make it an impromptu visit to Colorado on the 20th to sign some paperwork for a intermediate house to stay in. Our cousins who were going to loan us a house to stay in have decided to rent it to somebody else. So we're going out to secure another place that will be our temporary until the house is built. So
Nice
we have to go out
cousin.
and do a bunch of stupid stuff. So that means we get to leave 5 dogs in the kennel for a week. It costs more than the trip.
Oh, thanks for mentioning that link. I forgot about that, Jonathan. In the chat, I'm talking about, in case anyone's wondering. All right, let's go. If there's no more new business, let's go to observing reports. Anybody got any observing reports?
Ooh. This morning I was looking through my brand new eyepieces, a 5 and a 7 Pentax at Mars and various things. It was pretty clear this morning. It was cold as hell, but it was very, very clear. Orion looked pretty good last night. It's supposed to look out there. It's supposed to clear up tonight, but I haven't been outside yet. That's all I got.
Anybody
Yeah,
else?
Sean, I was out last night till about 3:30. I got Modes was out. A lot of the galaxies were out. Virgo cluster was out. M105 trio, the Siamese twins, everything, man. It was just beautiful.
Yeah, it seems like it's pretty clear too tonight. So might be a good time after this meeting to go back out.
It's going to be our last chance for a while.
Anyone else able to look up at the sky?
I have
Everybody here.
I have a non-observing report. I pulled out my PST solar scope the other day, and I hadn't used it in a month or two, and I couldn't find the sun with it because it was black. I remember a couple of months ago in the email lists, there was talk about some broken part on some of those PSTs that can't be replaced or whatever. And I couldn't find those, and I was wondering if anybody knew what or remember what that issue was. You know, with the PST, they have a little window that you try to get the white dot in there, and that's how you know that the sun, that you have a point in the right direction, all that kind of stuff. But that was never appearing, and no matter where I placed it, I was never getting the sun to come through through the lens. And so whatever filter or whatever's in there is broke or misaligned or something like that.
I remember what you're talking about, Tom. I don't remember who mentioned it. If no one on here has that information, what I can recommend though is if you go back on the Facebook page, because Jeff's posted all the links, you can scroll through, you know, those timelines.
Because I was trying to do that, but I couldn't. I might not have been going back far enough. I was just I just had to do a better scan of it, but I figured I'd bring it up just in case somebody on here was one of the ones involved in that discussion.
If you go up onto the group's IO page,
Uh-huh.
and send a message and call out Ted Forte on it.
Oh, okay.
Ted Forte
Ted was
had
in there.
he had a PST that had a blocking filter issue that rendered it inoperative, and I believe that he was able to have Mead fix it for him. I know that
Oh,
on
yeah.
their dedicated solar scopes, like their 60 millimeter and above, they have a little filter in the blocking filter that rusts and causes significant degradation of viewing. And I know that Mead will fix that for you, but on those, I had to have that fixed on mine, and they charged me $175 for a little tiny piece of filter.
Yeah, I think the price of those went up. I mean, just the scope overall. I didn't look for a replacement yet, but I'm a little afraid to. But I'm not getting. I mean, it's pitch black through the scope, no matter how bright it is and stuff like that. So it's almost like I lost, something shifted or misaligned. I haven't dropped it or anything like that. I've just been sitting. I actually had it sitting on a tripod for quite a while, and I just pulled it out the one day, and it wasn't. Couldn't blind myself.
If you find it's prohibitive cost to fix it, after talking to Mead or whoever, my recommendation would be a Lunt. Lunt makes I think a 35 or a 40 millimeter, and their product is superior. And
Oh, yeah.
their little filter, when it goes bad, costs you $8.50, and they'll send it to you in the mail.
Yeah, that's pretty good. Well, which company was that?
Lunt, Lunt.
Oh, okay. All right.
I
I'll
have
look
their
into
50
that.
millimeter.
There's quite a few members that have Lunts.
And because of that, I figured I'd buy a. Sorry, Sean.
Go ahead.
Because the one scope is going out, I figured I'd splurge and buy a little Big Blue Mead. I think it's a 80 millimeter, but they're on back order for like months and months and months. So I'm still waiting. As soon as the weather gets bad, I'm sure that's when it'll actually show up. Okay. All right, that's all I got.
I was just going to say that I went and looked on the Facebook page, and it could have been Ted, that meeting that we had Ted Forte give the presentation, and that was at the September meeting. So it's in the October meeting minutes about it. So if you want to go back and look at the September Facebook page, or not group page that Jeff, I know he posted a link on there, and you can scroll through that thing and see. Or you can also, like Chuck said, send an email directly to Ted. And if you need his email, let me know.
Thanks. Appreciate it.
You're welcome. Anybody else have any observing reports or non-observing reports?
Well, does anybody here remember Steve Shellman? Or a lot of you have met him or know of him. He lives up in Charles City County, and he's got a 30-inch Dobsonian that he set up out there. He invited Paul and myself up there one evening. He also has the eyepieces married to a white phosphorus night vision goggle. So it takes it and makes the scope look like a 60 to 90 inch scope. And the views up there was just fantastic.
That's cool. Now you're making me jealous.
I spent a couple nights, a couple weeks ago, out on the cold back deck looking at stars. I've got all but one object left for my urban award for the Astronomical League. And that object will not be high in the sky until another month. And Kendra, did you get that link I sent you? Good.
Yes, I did. Thank you.
All right. Well, if nobody has any more observer reports, we do have a presentation that Rich has volunteered to give on with the Beetlejuice?
Yeah, I was going to do something else and I was running out of time. So I was like, this is a subject I've already researched before in the past, so I could throw it together. Real
That's
quick.
fine. You do whatever you want, Rich. We appreciate them all.
And two, Betelgeuse is kind of a hot topic right now.
Yeah, we like Beetlejuice.
Don't say it 3 times.
There you go.
Too late.
Let's do this. All right. So as we mentioned before, we're going to talk about Betelgeuse. For one, it's just a fascinating star. It's eye-catching this time of year. Every time, the highlight of my dog's day is when we go out and get the mail. I always wait for the sun to go down. So she puts her nose down on the ground to sniff around. I look up at the sky. My house faces south. So this time of year when I'm going down the drive, Betelgeuse is, or Orion is right there in prime condition, looking majestic. It's the first place that your eyes go in the wintertime. And I typically stare at Betelgeuse and go, blow up. Like I want it to happen right when I'm looking at it. That would be, would just be amazing and really cool. Now, the odds are we probably got a good 50 to 100,000 years or so before that actually happens. But, people hit the lottery, right? And, but the other thing about Betelgeuse, like I would always look at it for years. I go out and look at it, but I never really took visual estimates of the star until last year when all the kind of craziness started happening with Betelgeuse, which started getting it some press, and up writing some articles about it. And I'm sure most people saw this this month in Sky Telescope. There was the article, "The Great Dimming of Betelgeuse" by Tom Calderwood. Tom is one of my counterparts at the AAVSO, for those who know, the American Association of Variable Star Observers, where I lead up the variable star, the long period variable star section. He leads up the PEP section, which we'll talk about what PEP is a little later. And it was a good article about what we think might have happened with Betelgeuse last year. So I won't get as many details around that. I'll talk about it some, but I thought it would be interesting, since that article just came out, to go over some of the physical properties of Betelgeuse, since it falls in my wheelhouse as a long period variable, and as a, and really how you can observe it if you choose to do so, and add data that scientists can use, because you really don't need any equipment other than your eyes. You can do if you want to get to some more sophisticated instrumentation with Betelgeuse, there are some, it is not easy to do by electronic means, and we'll talk about that. So again, why are we talking here? Here is, move this over here, 33 years of data captured by amateurs. This is all Johnson V data. So photometry in the V band. As you can see, Betelgeuse pulsates, or it goes up and down within a range of about 0.3 magnitude. And sometimes it dips down as low as about first magnitude. Then all of a sudden it dropped like a rock. Now these normal fluctuations in brightness from Betelgeuse is because Betelgeuse is a red giant star. It's an evolved star. It's moved off the main sequence, and it's physically pulsating. This is common. All red giant stars physically pulsate. And when these pulsations cause changes in their brightness. Betelgeuse also has what's known as a long secondary period. Its primary pulsation period is 420 days. It has another period of about 2,100 days. Again, that's not uncommon for these type of stars. About a third of red giant stars have a long secondary period. They're usually 8 to 10 times the fundamental period. Betelgeuse's is a little shorter than that, at about 5 times. And we don't really understand these very well. But with Betelgeuse, it has some interesting properties in that it's rotating about 15 times faster than it really should. It's rapidly rotating. We don't know why. One of the and that has some different ramifications for understanding the star, we'll get into later. But one of the consequences of that fast rotation is that it polarizes the light and it causes these deep convective flows. And that's what we believe drives the secondary period of 2100 days. So if you kind of look at some of these deeper dips where it gets down to about first magnitude, that's when the 420 day period and the 2100 day period kind of align. So you have these two deep dimming effects hitting at the same time and you get a deep effect. But then I always like this, if I watch CNBC in the morning, you see a stock chart and this is what would be the support level, right? About 105, that's the deepest it ever gets. And then last year around January, it busted through there and it was pandemonium. We're like, what the heck is going on? This is strange. And I took this data last year for an article I wrote, so I didn't have the recovery. So we were like, what's happening? Well, this is from the last 5 years. You can see a little better these fluctuations up and down from the pulsation modes, the convective flows. We have the deep minimum that dropped to about 1.8 in V band, and then it came back, and now Betelgeuse is kind of doing its thing again. So the question is, why did this occur? We had never seen this before. The other thing I'd like to mention about this is you see all this data again. This is data collected by amateurs. It's people who've been around me know I have a very passion about amateur science, and amateurs do play important roles in science. There is no professional data that's keeping these long-term light curves. There's reasons for that. Yes, we have all sky surveys. Everyone goes, why do we need visual observers? Why do we need amateur observers to watch these stars? There's a multitude of surveys out there. There's hundreds of them. Well, the brightest survey that I know taps out at 10th magnitude, and that's APAS. So APAS does not survey any star brighter than 10th magnitude because it saturates the detectors. A lot of the surveys in like the top end of the range is 16th magnitude. Stuff we could never see with our amateur equipment. So what is keeping track of stars that is 10th magnitude and brighter? It's amateurs astronomers. It's people who work for the AVSO. I say work, but volunteer and do this in their free time. They're hobbyists, and they collect this data that's being used by scientists now who are trying to figure out what happened with Betelgeuse. So a brief review of where Betelgeuse is, what it is star-wise. I throw this chart up a lot. This is the base, how astrophysicists categorize stars. So this is what's known as a Herzberg-Russell diagram. If you look at the bottom, it charts out spectral class, which is also related to temperature. We've gone over this before. So things on the left are hot, things on the right are blue, hot or cool, hot things are blue, cool things are red. So spectral class goes into color, it goes into temperature. And then on the x-axis, we're talking luminosity or apparent magnitude, absolute magnitude, equivalent things. So most stars reside here on the main sequence. These are the stars that are in their adult life, I like to call it. They're fusing hydrogen. This is where 90% of stars exist. And then as they age and they burn through their hydrogen, they start to evolve and they move off the main sequence back to the cooler, the redder parts of the HR diagram and become more luminous. So our sun, this is what we talked about last time we went over Mira stars. About 4.5 billion years will exhaust its hydrogen and it'll start traveling up the HR diagram as it becomes redder. And eventually it starts fusing helium, uses that up, you get an inert carbon oxygen core, sheds off its outer envelopes, becomes a white dwarf. Now, Betelgeuse started off much, much more massive than the sun. There's a dividing line at about 8 times the solar, 8 solar masses. Stars that are that large can start fusing heavier and heavier elements, unlike stars like our sun. So they go down a different evolutionary track. One of the things that we don't know well about Betelgeuse is what its main sequence progenitor was. We know at least was an O star. And most of the models return a star that went on the main sequence was probably 14 solar masses. One of the top modelers of Betelgeuse is a professor at University of Texas named Wheeler. He's thrown a lot of these out because people are like, well, that's what it was. And he goes, well, you're not accounting for the rotational effects that Betelgeuse exhibits. When he went and started adding some of these other parameters into his models, he found that Betelgeuse had to at least be 16 solar masses on the main sequence, maybe as high as 23, probably somewhere in 18 and 19 range. The other thing that we don't know about Betelgeuse, we don't have nailed down really well, is its age. Usually you age things, it's easier to age stars when they're in clusters, because what you do is hotter stars evolve faster than lower mass stars or cooler stars. So you find the hottest thing there, what's left, and you can use that by spectral class and use that to age a cluster, and then you know the age of the cluster. There's been a lot of work trying to tie Betelgeuse back to the Orion Association or the Orion Nebula, where the trapezium stars are, because these are also large O stars, which means they're relatively young. If Betelgeuse was bigger than any of those, and it's already evolved into its supergiant phase. The problem is we haven't been able to really do that. We haven't been able to tie Betelgeuse back down to the Orion Nebula, because there's a lot of theories, well, maybe it was born there and got ejected out, but we don't see those relative velocities. So because of that, we don't really know where it formed or how old it is. I mean, we can make assumptions based on doing spectral analysis of it, and we would say it's probably around 10 million years old. But there's a lot of uncertainty there. And that's the other thing to think about when you say, well, Betelgeuse was probably, say, 18, 19 times the mass of our sun. You would think it would last longer, right? Our sun is 4.5 billion years old. Betelgeuse is probably 10 million years old. It's already in a later evolutionary state than our sun, a state that our sun won't get to for another 4.5 billion years after this. It takes 10 billion years for a sun. It's because they go through different nuclear processes. They burn through that fuel so much faster than lower mass stars like our sun. So one thing about Betelgeuse blowing up, like I said, I always say, come on, blow up, blow up. One thing we do know, if you look at this evolutionary track, when Betelgeuse was on the main sequence, it would have started up here. It jetted across the HR diagram and is now over here. So based on its spectral class, we know that over here, this is still it's probably still in the helium burning phases. When it starts fusing heavier and heavier elements in its core, it's going to start heating up again. When it starts getting hotter, it's going to start becoming bluer and bluer and bluer. So that's something to look out for. Is its evolution. When we start seeing this, we can start getting some indicators that it's going to blow up. We have the ultimate indicator, because one thing is about these larger stars is the fusion actually happens in a shell-like structure. So as it moves to heavier and heavier elements, you start getting this onion-like structure developing inside the star. We'll have a great indicator that this thing is going to blow up when we get to silicon and sulfur. The reason is when they start silicon and sulfur fusion, the star will emit a ton of neutrinos. We saw this when right before supernova 1987A went. All of a sudden, all the neutrino detectors in the across the Earth went crazy. People were like, what's going to happen? And all of a sudden, in the Large Magellanic Cloud, something blew up. So we will get some indicators. Betelgeuse is about to blow up. Not a huge warning, because this state, it will only take about 12 hours for Betelgeuse to finish fusing all the silicon and sulfur it has in its core, making nickel and iron to an inert core that it can't fuse, and then imploding. So you'll have about a 12-hour warning that this sucker is going to go. I always like things to scale to kind of grasp how big Betelgeuse is. Now, there are bigger stars out there. Like Mu Cephei is orders of magnitude larger than Betelgeuse. But if you look at what our sun is size, and then you look at the scale of Betelgeuse, this is what they would look like next to each other. Betelgeuse is about 600 times the radius of our sun. I did the math the other day and came up with a radius of about 5.2 AU. So if we plucked Betelgeuse into the position of our sun, it would extend out just past Jupiter. And that's just the photosphere of Betelgeuse. The photosphere is where light becomes opaque. So it looks like a surface, even though it's not a solid surface, it looks like a surface. It would extend past Jupiter. Betelgeuse, like many red giant stars, because when they as they evolve and get to these later stages of life, they start ejecting large amounts of mass, which is going to become critical with our dimming conversation. So Betelgeuse has extended hydrogen structures or a circumstellar envelope where heavier metals also condense, that if we put it into our solar system, it would extend past the Kuiper belt. I have some pretty good hydrogen maps of Betelgeuse. It extends for massive, I think somewhere in the order of 30 or 40 AU. So it's big. The other thing that makes it a great thing to look at or study is because, there are bigger stars like Antares, you can see from this picture, is larger, but they're much further away. These red supergiants are really rare. The same, the stellar class that Betelgeuse belongs to, I looked in the variable star index and found 101 similarly classed stars. This index holds over 2.1 million variable stars. And so there's 101 like Betelgeuse. So they're pretty rare, and they don't last in this phase that long, and they come from O stars, which is about 0.1% of stars that are born. So, but Betelgeuse is relatively close. It's the closest of these supergiants. It's about 200 parsecs away, or 600 light years. So it's large enough and close enough where we can actually angularly resolve Betelgeuse. We can't do that with any other red giant stars. That allows us to study surface features of Betelgeuse, one of which was taken by the Very Large Telescope in Chile. As you can see what was going on last year. In January 2019, it took this image where you can see angularly resolve it, and it looks like a normal star. Back in December, it took another image, and you can see that it's dimmer, and also that the dimming was somewhat localized. It wasn't uniform. So this coincided with that huge dip in the V band that we saw, but it was localized. So again, what was going on? Well, here's more amateur data to try to wrap our heads around what was going on. So again, here's 6 years worth of amateur data. So here's V band. This is visual optical data. We see the dip. Up here, you see near infrared data. This also was collected by amateur astronomers. If you see that Betelgeuse doesn't pulsate as much in the infrared as it does in the visual. Also, I'll show black body radiative curves, but because of the lower temperature of Betelgeuse, it radiates a lot more energy in the infrared than it does in the visual, which you can see that by how much higher these magnitudes are. So this is 4th magnitude in H band, which is 1.6 microns. This is J band, 1.2 microns. It didn't dip, but it's normally about 4 to 5 magnitudes higher, which would correspond to as a log scale about 62 times brighter in H band than it is in V band. It dips slightly, but not very much. Now, that would be indicative if you had, one of the main theories was some sort of mass ejection. So if you had dust being ejected from Betelgeuse, the dust would be opaque to visual light and it would dim, as you would see here. But it would also not dim because the dust would not block infrared light. Dipped a little in other higher, even longer wave bands. We saw some dip, which tells you it maybe not dust. One of the other issues with the dust theory is that the optical light should warm the dust and actually increase, causing infrared excess, something that we also didn't see because it heated the dust. These are the curves I was talking about. I know I've showed these before and gone over them, so I won't spend a lot of time. But So if you have something, anything that has temperature emits light, right? You're emitting light. It's just in the infrared and our eyes can't see it. These very cool stars emit most of the light in the infrared. Betelgeuse is about 3,600 Kelvin, and it emits a lot less in the visual light. So they're peaked over here where you saw the I band, which would be about here, J band about here. So most of the energy is in these higher orders. That's going to be someone talking, and it doesn't do a lot in blue light. So if we look at when Johnson set up his pass bands in the 50s, he has the B band, and then he also set up the B band. One of the reasons he did it like this is kind of low res spectropathy, is if you take what he calls a color index, take the V magnitude, subtract the V magnitude, you can use that to extract temperature. So one of the things I did, you would look for is did the temperature decrease during this event? I went and plotted it out, and I couldn't find statistical significance to do that. I know some other guys like Dr. Wasatonic at Villanova looked at wing band, which studies titanium oxide, and looked for temperature. He saw a little bit of temperature decrease, maybe 100 degrees at most. Again, that would lend the dust theory out. The other main competing theory was, excuse me, 1 second. Somewhere in my pajamas. The other thing that it would, the other theory that was out there besides dust, which has some things going for it and things not going for it, Tom Calderwood did more justice in Sky and Telescope, was maybe it was a convective cell that rotated in a line of sight. As we can see, this is VLA data, which is showing all the light polarization and how it moves across the structure in Betelgeuse. They did a multi-year study of it. So you can see these cells rotating in and out of the line of sight. So it could have occurred if a really large convective cell came across. The problem with that is, okay, that fits, but also why have we never seen that before? So is it dust? Is it convective cells? Some kind of thing in between? We don't know. We need to study it more. And people are going to study it more. So one of the things they're going to need in order to do that is they need more amateur observations. And so you can easily do that. I'll show you how, just visually. I know for one thing, like I said before, in the beginning, I always looked at Betelgeuse, but I never went up and made a visual estimate. I never went and logged it on the AVSO website. I thought there was no point. Well, last year with this dimming thing going on, I'm like, yeah, okay, I'll go do it. So every night when I was getting the mail, I would go out and make an estimate of the brightness of Betelgeuse and go and log it at the AVSO. I ended up taking 56 visual estimates, and every week, the AVSO staff sends you out an email of all the data downloads. You know, I submit all kinds of data and observations into the database, and they say what's being downloaded and who's using it, whether they're professional astronomers, students, whatever. Every week I get 6 to 8 usual data downloads of my the observations I turned on in Betelgeuse. So it's always the top hit. That's the one that people are downloading the most right now, and have been for several months. So if you wanted to go out and do it, this chart here's a chart to make your comparisons. This chart came from the AVSO calls their 10-star tutorial. It's easy naked eye stars for a new observer to go out and get comfortable making estimates before doing it at a telescope. And so you take this and you go find Betelgeuse. Now, one thing I don't like about this chart is a lot of the stars that they have for comparison stars, the comparison stars are all the ones with numbers by it. So they're saying, okay, this star here is 1.9 magnitude. This is a 3rd magnitude star. So you would go find Betelgeuse. Ideally, you would find a star just a little dimmer, just a little brighter, and say it's in between those, then try to do some interpolation to figure out how bright it is. One of the issues with this is Betelgeuse is an extremely red star, as we showed before. So not all of these stars are really suitable. You know, maybe they're more suitable for Edagenorum, a star I don't mess with. It's an eclipsing binary like Algol. Boring. Well, they're not boring, but they are to visual. Okay, they're boring. Never mind. So a lot of these stars don't match up well color-wise, would not be suitable comps. So on a night like tonight, if it was clear, you have a pretty good comp star in Aldebaran, which has a similar color. You know, Alpha Ori's B minus V is about 1.8, very red. Aldebaran is about 1.5. One of the problems with that is being a red star, Aldebaran is also variable, although it does not have much of an amplitude, so you can get away with it because most visual observers are not going to have that level of precision. Aldebaran, I think its range is about 8.6 to 8.8, maybe 8.9. So it has a pretty low amplitude, well within the use. The other one you would get tempted on the top side right now is to compare it to Procyon, but Procyon is a very blue star, and your eye has and we talked about this one before, different eye response to very blue light to very red bright. So Betelgeuse, your eyes would be tricked into thinking Betelgeuse is actually brighter than it is. That's one of the reasons why when it was very tempting when Betelgeuse was really down at its minimum, you saw a lot of stuff saying, do not use Bellatrix as a comp star. People were tempted because it was similar magnitude, but the color difference was just too great. I was end up using Pollux as my comp star for the most part when Betelgeuse was really down in the dirt. And I'll show you if you want afterwards how to log that at the ABSO website. It's really easy. It takes 5 seconds for a star like this. So you would go out, like I said, I have pretty good calibrated eyes from years of experience doing this. Right now I go, how many tenths of a magnitude does Betelgeuse look than Aldebaran? So if you want to get more sophisticated than just using your eyes, and you wanted to do, measure it by some electronic means, there are some definite challenges here with Betelgeuse. For example, this is, take it back. So if you go out and make some visual estimates, you'll go in the database. There's a lot of people in here like this, and then you can do averages because if you can see the grayed out, those are the actual observations that people logged. So there's a lot of scatter here. A good visual observer can get within 1/10 of a magnitude. Bad ones usually are like 3/10 of a magnitude. Due to lack of great comps, you're going to get even more scatter with a star like Betelgeuse. But if you have enough people and you have, you can bend some averages and get good data enough where you could do time series and look for things like period changes and doing that sort of analysis. So it works. And like I said, people use it. I get data downloads from this all the time. Now, if you want to step up and do some CCD photometry. So how does CCD photometry work? This is from a different star that I study from ABSO's remote stars, Y Persei. So typically with a CCD, you image a field, you identify your target, you measure the flux at some known sources, and it just ratios it. And it figures out what the instrumental magnitude of your target star is, and then you have a check star to kind of do error analysis. Simple, right? Well, is that simple for Betelgeuse? One of the problems is Betelgeuse is insanely bright. So you are going to saturate your detector on your CCD within fractions of a second if you try to image it. Now, and most CCDs have very small field of view, so you're not going to have any star anywhere near as bright as Betelgeuse in your field of view. And you're going to saturate, in most CMOS cameras especially, you can go fractional seconds on those suckers, but you're not going to be able to resolve any comparison stars with enough signal to noise ratio to be useful. So there's just no way to measure it with a traditional CCD. So there's an old school method known as PEP to get around this. So how would you get around it? This is what a photometer that the PEP specialist uses. This is what Tom Calderwood uses, is he leads up our PEP section. This is what's used for really bright stars. And it's old school, but it's an insanely accurate method. All this photometer does is count photons. There's no imaging, no fancy data reduction, no taking flats, no taking calibration frames, and all the other stuff that you do with CCD photometry. You point this at Betelgeuse, you count photons. You turn it on, count photons. Well, you still need something to compare it to. So you put this on, you count photons, then you go to you slew to a different star, your check star and your comp star, and you do the same thing. Then you come back, do Betelgeuse again, your check, your comp, and you do that 3 or 4 times. The PEP section of the ABSO has a list of every star. So if you say, I want to do this star, it'll say, this is the check you're going to use. This is the comp you're going to use for consistency. And then you put that into a spreadsheet, you do some math, you do some transforms, and you come out with your magnitude for, say, Betelgeuse. Works really well, but it's time consuming, so a lot of people don't like doing it. The other thing that's interesting, when I showed earlier, when I showed that J and H band data, you can only get that data, those near infrared bands, with something like this, because CCDs lose sensitivity at about 1,000 nanometers, and we're at 1,200 and 1,600 nanometers. A CMOS even has less sensitivity into the red. They usually tap out about 800 nanometers. They lose sensitivity. You can't even really get good I-band data with CMOS cameras. So when this great dimming event was occurring, there was an observer out in Arizona who was looking at some of the Johnson V data, and he thought there was a little too much scatter, and he wanted to image Betelgeuse with his CCD. But we talked about the challenges why you can't really use a CCD for this kind of imaging. Well, he found a way around that. He engineered this super high-tech device here by putting cardboard over the front of his 13-centimeter telescope. First, he punched these 2 holes in where the white spots are, but he found out that he was Betelgeuse was still saturating his detectors too quick. So he taped over them and punched those 4 smaller holes in. And now you still don't have the field of view to really to do normal differential photometry. So he used his telescope and he went and used PEP methodology, where he would image Betelgeuse. He used Aldebaran as his comp star, and then he used Phi 2 Ori as his check star. He gave his presentation at SAS this year. And he also wrote a paper where he did, because he needed to convince himself that his method was correct. So his paper has a lot of the statistical analysis that he did to really eliminate many of the errors. That was, one of the reasons he had the 2 hole, he stomped it down even more, is because he was trying to reduce scintillation. You at least want 10 seconds of exposure, because that will help narrow down atmospheric distortions. The reasons he picked Phi 2 Ori, not only had a decent enough B minus V, there are not many red stars in this area, but also had a similar declination, so he can image the star when it was at the same altitude as Betelgeuse, so he can eliminate secondary extinction from air mass. Because if you shoot it at different altitudes, you have more atmosphere to go through, so that causes more secondary extinction, so that adds a little bit more to your error. So he adopted this method in order to actually image Betelgeuse with a CCD, and he got really good results. Like I said, he did a very thorough analysis of his errors. And if he wants the paper, I can share it with you. That's all I have. I probably had more, but I know I talked a lot. I don't know if anyone has any questions, or if someone wanted me to show how you could go into the ABSO website and actually log and log a visual estimate, I can do that too. Did I talk too fast and too much?
No, that was good, Rich. Can you show people how to do that?
Sure.
Because you said it's like a 5-minute thing, right?
Yeah. Oh, yeah. It'll only take a second. So let me share again. Which is the right screen? Where is my web browser? I see all these other things I can share that no one wants to see. Why do I have so many things open? I feel like George now that I can't properly, even though George knocked out the sharing right off the bat. There we go. You see the AVSO website? We good?
Yeah.
Okay.
We see it.
All right. So avso.org. So say I went out on a night like this. I looked at Betelgeuse. I would look at Aldebaran. Aldebaran's 0.9, and say I thought it was 0.2 of a magnitude brighter. I'm logged in. I would come to tools for observers and resources. One thing you will need is an observer code, which you can request. You don't have to join or pay anything for that. If you become a paying member, you just get access to a lot of these other software things that I use a lot, which are really good, and access to AVSO mentors. But I am a mentor, but you don't need to pay to get that because you could just call me. So I would log into WebOps is where you upload your data. Yep. Select individual observations. I'm selecting a visual observation. They have stuff for CCD, PEP, DSLR. Usually, if you're doing that, because there's a lot more data, you would have they have a format in Excel or a text file that you would do. So I would just plug in the star identifier. You do need to know your Julian date. They have a Julian Day Calculator. That's what I normally do. Is it going to switch over for me? Did it switch screens? Do you see a different? Oh,
Yeah.
Okay. So say if I did it for right now, I would go to their Julian Day calculator. I could put in the time, since I don't know Julian dates off the top of my head. And it's February. You got to put this in UTC. So right now we're 5 ahead. So it's like 1:30, right? So I come in and put the time in UTC of my observation whenever I was out and looked at it. It gives me the Julian date, and I copy and paste. Come back over. I can put the Julian date in. Enter my magnitude. So if I thought it was 0.2 brighter than Aldebaran, I would make it 0.7. My comp star was Aldebaran, which is a 0.9. I could put in a second comp star if I used one. My chart ID was the 10-star tutorial, and then I would submit, and that's it. And it keeps the log. You see a couple of days ago, I've done similar observations on Betelgeuse. And then these other ones over here are CCD observations. So you see there's a lot more information that goes in as far as like errors, your filter, use a ensemble, all that kind of stuff. So that's all you would do. You can, like I said, if I go out to mail, if I look at Betelgeuse after I come in, I go 5 minutes, plug that in, hit submit, data's logged, and then it goes into the light curve. So when someone comes in and says, I want to look at Alpha Ori and plot the light curve, the points are in there. You can even go in and highlight the ones that you did. So if I go down here and find my observer code, RRIA, here's me. So all the ones in orange are estimates that I made.
Wow.
Easy peasy.
Impressive, Rich.
Impressive, yeah.
Thank you.
Well, Rich, what do you mean by I band and J band and all those other bands? What are you talking about?
Okay, so there are different photometric sensors. So those are the filters that are used. So the most, I don't know if I would say common anymore, but since the 50s, the main photometric system has been the Johnson passbands, which Johnson came up with UB. I probably have some better slides on that of what frequencies those entail. And then Cousins came in, he came up with a R band and an I band. Now there are a lot more bands out there as different surveys keep adding stuff. So now you'll see there's Sloan pass bands, which were used by the Sloan Digital Size Survey. Those are starting to become more favored by professionals. And you can buy Sloan filters now, and they have all the, they have their own pass bands. J and I are similar. They're just pass bands where we are allowing certain frequencies through, and they're in the near infrared. But there's a ton of bands out there. Let me see if I have a visual. I think I have a slide on there when I did the Myra presentation. If I can get that real fast, I'll put it up. All right, let me share again. I almost put this picture in there as one of my favorites. Myra's stuff. I think I had the pass bands in here. Yeah, so the most common photometric system that you'll see, even though it's being phased out more in favor of Sloan's, is the Johnson Cousins pass bands. And so one of the reasons professionals are kind of moving away from this, because Sloan's are way more defined. The curves are the sensitivities at those certain wavelengths. And so Sloan will refer to this pass band around visual as the G band around green. We call it visual because it is most like human eye response. So Johnson originally came up with these bands, V, B, and U, and he did them for specific reasons. His main reason was because if he could take the B magnitude and subtract the V magnitude, he would have an indicator of temperature. If he took U minus B, that would be Balmer jump. So that would show excitation of hydrogen atoms. You're only going to see this in very hot stars like O stars that are have enough ultraviolet light out there that they can actually excite hydrogen out of its lowest energy level. And then Cousins came a couple of years later and he extended it out with his R band and I band. Here's another image of that. And this is the Johnson Cousin pass bands and where they're sensitive. And here's the human eye. This is a eye that is not dark adapted. This is a dark adapted eye. And so that's kind of important to realize is your eye sensitivity does shift as you become more dark adapted. And if you look at stars and you're trying to compare your eye to photometric data, it's not always going to be consistent. A lot of people think, oh, if I don't align with the V magnitude, I'm off. Well, if you're well dark adapted, you should be somewhere between B and V. And that's also going to change by stellar type because the really red stars, which are where I typically observe since I'm a long period variable guy, I deal with cooler stars that are more shifted into the red. And so a lot of times it'll even be a more drastic effect. So that's a quick down and dirty on when I say J band or V band, B band. I know V and B kind of sound They kind of run together a little bit when you're talking. Probably why Sloan used G instead of V. Anybody else got? I know I had to leave some stuff out or leave some head scratchers there. I know a lot of the I breezed. The other thing is too is a lot of the topics I kind of went to some base astrophysics where I'm like I've talked about some of this in more depth on other presentations, but not everyone saw all of those presentations. So, you know, but I'm like I can't cover everything. I was kind of brushing through some.
So to recap, what's the prevalent theory now for Betelgeuse's dimming? I mean, you went through several of the scenarios. Is there a main theme or?
No, it's kind of split. Like I said, we've kind of settled that like people say it was probably either the dust ejection or convection cell. Both have things going for it. Both have some issues. So there is no consensus there. But those are the two kind of main theories. And the other thing is kind of weird about the dust theory. It checks a lot of boxes, but it's kind of like, why does it coincide? You were also coinciding with its expected deep minimums anyway. It just seems kind of coincidental that you'd have a mass ejection really dimming it when we were already expecting it to be dimmer than usual, but just not to anywhere near this, this magnitude.
And another, probably a dumb question, but you said that the dust wouldn't block certain types of light. Why wouldn't it block all light? I don't understand.
So it has to do with wavelength and size. So bluer light or optical light, it has a really short wavelength and is, and when you start getting to infrared, it start in radio and stuff, it has longer and longer wavelengths. So these dust grains are small. So they are very good at blocking small things, but large waves can go right through. Okay. And so that's why like a lot of our mapping of like the universe and stuff, we look at like things like the cosmic background. We can look at it from so far away without any interference because it's really long wavelength stuff. When we map hydrogen, we look at the 21 centimeter line, which is the spin flip between its ground state. We do that because those wavelengths are so large that nothing can attenuate it. But if you start looking at gamma rays and X-rays, that stuff gets attenuated really easily. So with the dust grains, remember, these stars like Betelgeuse are cool enough where molecules can actually form. You know, our sun, there's no molecules in its stellar atmosphere because it's too hot. It just disassociates all of them. But when you get to these cooler stars, you start getting things like titanium oxide and different aluminum compounds, and they attenuate and block light in the visual parts of the spectrum, but they're not large enough, like the larger wavelength infrared light can just go through.
Oh, thank you.
So that's really what's going on there. That's a good question, actually. Think we go out and observe Betelgeuse now? Take some.
So, Rich, I've never done any entries into the database you just showed us, right?
Mm-hmm.
And I don't want to put in bad data. So, what's the easiest way to, when you look up there, to be able to tell? Like, if you can't.
This is one thing I did a lot. Go back to sharing.
I'm willing to bet that a lot of people would be entering if they thought they were giving you good data.
No, I get that. There is definitely, a confidence building type thing. So
put something in there right now, don't mean it's right.
Well, you also can't assume, but one thing I would do is, so say you went out and you took you looked at Betelgeuse and you're like, I think it was this. I think it was 0.7 or 0.6, whatever you thought it was. you could come in here. This is the homepage of the AVSO. And pick a star. You can put in the star name. We have naming conventions for buyer designations. So all alpha stars are just alpha. The one gets confusing if you have like Muse. It's always 3 letters, MIU. But there's guidelines of star naming conventions. So I put in alpha orate and I say plot the light curve. So this is what the data that's gone in. The black dots are visual observations. The green dots are Johnson V data. And if I went in here, I can also select more bands if I wanted to. But I would look at what other people are putting in and see if it makes sense. As you can see, there's quite a bit of scatter here.
Yeah.
And so this is kind of a hard star to get really nailed down. But I would, if I was consistent with what other people said, I would feel confident. When I first started doing variables, I used to like, maybe a better start is, it's a little easier to see. I would come in before I would put my data in to see if it made sense. So here's a pretty standard Myra star, R Cygni. And so I would come in and go, if I was out there and I was kind of in the ballpark of everyone else, okay, I'm doing it right. I did that a lot when I first started out. Now I don't go and really check myself because I figure I'm right and other people should use my stuff to check me. But when you're starting out, you know, I definitely did that. I used to come in and look at these light curves to kind of see if if what I thought it was when I was out there, if it made sense. And if it didn't, I probably wouldn't put it in, or I would try to figure out what I did wrong. Whether, you know, because there's been times where I go back and I go, man, I probably had the wrong star. I was like, look, when I was at the IPs, I may have looked at the wrong star or something like that.
Okay. I mean,
Betelgeuse is hard to miss.
These black circles are the visual observations?
Yes.
I'm looking forward to when we're in person again and I can say, hey, Rich, what do you got? What do you think this star brightness is? Then we could compare. Then I'll know because I get real-time feedback.
Yeah, and that's one thing you can also do. Like I've gone out too, if I'm just stargazing to kind of like get some calibration going, is like you can look at, you know, if you had a sky chart and look at naked eye stars, and if like a star is 4th magnitude, you try to pick out stars that you know their magnitude and kind of get that feel for it. When I'm at the IP, I got pretty good at calibrated where I can just kind of glance now at a star at an eyepiece and go, okay, that's about 9th, that's about 8th, and then I can refine from there. But the more you do it, just the better your mind gets at looking at a star, especially in your own equipment and knowing about what it is, and then you can really start to dig in a little bit more.
I'll make an effort to actually do that so I can better train my eye so I can enter that data. Because we all, obviously, we're all looking at stars. That's kind of what we do.
Yeah. Yeah, that's why I try to use the time. Because like I said, for a lot of these, maybe not as much Betelgeuse, but some of these other like Myra stars, for example, that are above 10th magnitude, is visual observers are the only ones who are keeping a record of what they're doing. And a lot of these visual records that the AVSO has span over 100 years. And people can use that data to try to find out changes and better understand the structure of these stars, especially things like Myras, which are at the very, very end of their life. They're rapidly evolving, and that's how we understand their evolution. Most of it's from amateur astronomers. And now we might be collecting more photometric data, but the problem is we don't have any history of record. You know, most of that photometric data might at best start from the 50s or 60s and really don't have a critical mass of it since like the 90s, when it really became affordable to amateurs to have that kind of equipment. So the things that we learn, and there's no real way to go back to the 100 years of visual data and translate that into photometric data. The photometric data is going to be useful way off 100 years in the future when we have 100 years of Johnson B data on stars. But now we understand or monitor for changes in these stars that are key to understanding their evolution, mainly from visual observation. So they still need to continue. And like I said, if the star is bright enough, it doesn't get touched by surveys. It's really only people like me that are out there keeping track of them. But Betelgeuse is easy to do if you just wanted to get some observations in there. And like I said, a lot of times you don't have to set up. Just like I said, I do it if I'm going to get in the mail. I'm like, all right, let me just catch Betelgeuse and log it.
It reminds me, get the mail, it's still in the box.
But if you really want to get into things, you know, Bruce was talking about AL programs. There is, I know I mentioned it before, there is a variable star AL program. It's not that hard. I think you do have to follow Amira for like a year.
I've been a slacker on those AL programs. I'm gonna have to get into it.
You know, when George mentioned his Urban League, I was like, oh, I did the binocular Messier program. I had 47 of the required 50 I needed. So I'm like, maybe I'll go back and revisit that. Then I was like, is there anything up now? I'm like, oh, I've got all the winter ones I can get. I gotta wait till like summer before I can start probably checking off a couple that I haven't got. And I started when I lived in Hampton, so I picked up well over a magnitude since I moved to Isle of Wight, so it'll probably be easier now.
Very good, Rich. Enjoyed it.
Yeah, thank you.
You're Rich.
Thanks.
I'm giving you a round of applause right now.
All right, cool. I'll take it. All right, guys.
Well, I guess if we got nothing else, anybody got anything else to add?
Don, you still thinking about 3D printers?
You betcha. I'm definitely thinking about it. In fact, you stay on, I'll talk to you.
Okay, I can stay on.
All right.
Hey, Sean, there was a question from John, got his name, last name. Anyway, somebody on Facebook wanted to know if anybody had an Revolution Imager R2. Is that what you have?
Yeah, I responded to him.
Okay.
Yeah, I saw that. I responded to him.
Yeah, I saw that also. I've got one of those too. It's pretty frustrating, at least if you want to hook it up to a computer. I mean, to look at it on the video, the screen they give you,